Hi, I'm Bhoj Raj Pangeni. You are welcome to the finance class. In today's lesson, we are going to discuss about the very important topic in finance, that is time value of money. What is the meaning of time value of money? Time value of money. Time has its value, monetary value. That means rupees 100 today is more worthy than rupees 100 a year after. That is the because of time value of money, because the 100 can earn the extra return, or we can say the interest is our the value of money due to the timing. So time has a significant value, monetary value. It affects the financial decision taken by the manager or any personnel. So first of all, in this video you have to compute the different kind of cash flow and their present value and future value. First of all, we have discussed about the future value. Future value means present value and future value. 0 year, at 0 year this is the present value, and at after 0 year that is called future value. Have a look on the formula directly. We are going to discuss numerical parts only. So FB equal to PV 1 plus I to the power n for single cash flow. What does it mean by the single cash flow? Have a look on the timeline. Year 0, 1, 2, 3, 4, 5. This is the year 0 to 5. 0 is present date. That is now, today. Now is year 0. And after year 0, that is 1, 2, 3, 4, 5. That is called the future time. I equal to interest rate. I equal to interest rate. N equal to time. I equal to interest rate. And have a look on cash flow. Rupees 200 at today. That is 0 year. Cash flow at 0 year 200. Then after year 1, 2, 3, 4, 5 there is no any cash flow. So in this timeline there is only one cash flow. That's why it is called the single cash flow, because there is only one cash flow. And the at year 0, this is the present value. 0 at year 0 is the present time, and rupees 200 is the present value. Then what is the value of 200 after 5 years with 10% interest? That is called the FP for 5 year. Then in this cash flow we can get the information about the present value equal to 200, interest rate I equal to 10%, and number of year n equal to 5 year. We can easily calculate the FP by using the above formula. So where FB equal to future value, PV equal to present value, I equal to interest rate, and n equal to number of years. And the above cash flow, we consider there is no future value, but there is a present value I and n. PB, I and n. We can easily find out, if we get the PB, I and n, we can easily find out the future value. So we know that the FB equal to PB 1 plus I to the power n for single cash flow, and the value of PB, I and n we can put it. And be consider about the I equal to 10%. 10% you are not allowed it to put directly as a 10%. 10% means 10 upon 100, that is 0.1. Put it in this way, 0.1, or 9% equal to 0.09, 8% equal to 0.08, 15% equal to 0.15. In this way you can divide it the percentage rate by 100. So we can get the future value rupees 322.1 that is called the future value. It means that rupees 200 is equal to the rupees 322.10 after 5 years at 10% compounding rate. We consider the finding the future value. The process of finding the future value is called compounding, and the finding the present value is called the discounting. Present value, discounting; future value, compounding. Always used. Now this is the time for calculating the present value. Now it's turn. Present value, we have discussed about the future value. We already know the formula FB equal to PV 1 plus I to the power n for single cash flow. We already know about that. Now we can calculate the PV from this formula also. PV equal to FB divided by 1 plus I to the power n. 1 plus I to the power n is goes to the FB side by dividing. We can get directly, or we can compute from any two formula. We can, there is no any difference. So consider the, again consider the same timeline. Cash flow FB equal to, we don't know about the FB, PV, sorry, PV, but we have a FB information, that is cash flow at year 5, that is rupees 322.10. This is the cash flow of year 5, and there is no any other cash flow, so it is a single cash flow. And I equal to 10%, n equal to 5%, and PV equal to what? PV means why? Because there is a 0 year. Year 0 is the present date, today, now. So this is the present value. We know that present value, the formula of present value equal to FB equal to PV 1 plus I to the power n. We can directly put the value. We get rupees 200, or we can directly put the PV formula FB divided by 1 plus I to the power n. FB equal to 322.10 divided by 1 plus I equal to 10%, that is 0.1. So, and the n equal to 5 year, so we can get 200, that is present value. Now FB and PV both are computed, but I and n, it's done for interest rate and time, number of year. Now the problem of interest. Let's assume the future value equal to 322.10, present value equal to the rupees 200, and time n equal to the 5 year. Then what is the value of interest? We know that the again same formula. From the same formula you can use from same formula by putting the FB PV 1 plus I we don't know the interest rate now, and the n equal to 5 year. We can get, now this power 5 is goes to the 1 upon power 5 from another side. Now we can get the I equal to 0.099999, that means 9.999 is equivalent to 10%. So the interest rate is 10%. Now it's time for calculating the time or number of year. Time n equal to what? Again we assume the future value equal to rupees 322.10, present value PV equal to rupees 200, I interest equal to 10%, and what is the value of time? Again we know that the same formula FB equal to PV 1 plus I to the power n, same formula we can use, the same formula. FB value, put the value of FB, PV and I. We don't know about the time n, so then now Now 1.1 to the power n equal to 1.6105. We cannot compute directly and we cannot get the value of n. So in this situation we have to use logarithm log formula, that is taking log in both sides. Taking log in both sides means log 1.1 to the power n equal to log 1.6105, and use the formula log m to the power n equal to n log m. This is the formula. Use this formula log m to the power n equal to n log m. Use this formula. You can easily compute m. Here is the log 1.1 to the power n. In this equation, the log 1.1 is assumed as a m value and to the power n is n. So log m to the power n. It means that n log 1.1 equal to log 1.6105. Now n equal to log 1.6105 divided by log 1.1. Don't cut log and log. You have to find the value of log 1.6105 and the log 1.1 and divide it. 5 year. We can get 5 year directly. So this is the single, all about the single cash flow. Now we are going to discuss about the loan amortization schedule. Loan amortization schedule means that schedule where the loan is amortized to the zero value, that is fully amortized, or loan is decreased. So have a look on some formula, that is installment loan basis. It is used for installment loan. So have a look on formula number 1, PMT. PMT means equal annual installment. Equal annual installment means PMT. PMT means loan amount divided by PVIFA I percent in year. Or another formula, you can directly compute the PMT without financial table. If you don't have a financial table, use another formula, loan amount divided by 1 minus 1 upon 1 plus I to the power n whole upon I. You can easily compute from this formula. If you don't have a financial table, value of PVIFA I percent in year can be obtained from financial table. If you have a financial table, use the easiest formula, that is the loan amount divided by PBIFA I percent in year, where PMT means equal annual installment that is equal, and the installment that is annual. So PMT means the equal annual installment or payment, whatever PMT means. Also we also known about the PMT as a installment. So PVIFA, present value interest factor of annuity. Don't use the PVIF, always use the PVIFA. It's an annuity. It's an annuity, so use the annuity factors, not a single cash flow factors. Please be considerate about that. PVIF is not used here. PVIFA. Only consider the PVIFA because it's an annuity. So present value interest factor of annuity, and I equal to interest rate per rupee, or we can say the percent if it is given in percentage. N equal to number of year. Now the number 2 formula, the portion or fraction of interest of T year represents the payment. That means any year of interest, what percentage of payment represents the interest rate of any year. Is in this formula, the interest of T year divided by PMT into 100%. You can write the percentage as a unit. And the another formula number 3 is portion or fraction of principal of T year represents the payment. that is principal of T year. In number 2 formula, that is the interest, but number 3 formula, that is the principal. So principal of T year divided by PMT into 100. Now we're going to solve the question. Read the question carefully. Suppose M's college wants to borrow rupees 10,000 from NBL at 10% for 5-year installment loan. Here is the installment loan. So we consider rupees 10,000 is our loan amount and 10% is our interest rate, and 5-year is the number of year, and we have to this loan is the installment loan. It means that the college will pay the loan by installment, yearly installment. Now required equal annual installment amount. Equal annual installment amount means the amount of payment, PMT, and B, fraction of payment represents the third year interest. C, fraction of payment represents the fourth year principal, interest and principal of last year. For B, C and D, we have to prepare the loan amortization schedule because we have to know about the interest of third year. We have to know about the principal of 4 year and the interest and principal of fifth year, that is last year. So for this information we have to prepare the loan amortization schedule. Let's go to the problem 1, equal annual installment. First of all, we have to write the given information: loan amount equal to 10,000, interest rate equal to 10% per annum, time equal to 5 year, and a annually equal installment PMT equal to what? We know that the PMT equal to loan amount divided by PBIFA I% year on year. Loan amount equal to 10,000 and PBIFA I% year on year. I% means 10%, year on year means 5 years. So have a look on PBIFA table. I% means 10% 5 year. Look at the PBIFA table, 10% 5 year. We can get 3.7908 as a factor, PBIFA factor. So we directly used it and we can get rupees 2637.9656. This is our annual equal installment. Now we have to prepare about the loan amortization schedule. This is our format. Have a look on the format, and the red color is highlighted because it is very important and it makes us easy to calculate. Now the years is 1 2 3 4 5, and the beginning balance of loan, that is we note it as A, and the payment we note it as B, and interest we note as C, and principal is D. Ending balance we don't need to note. Now the beginning balance of loan A, payment B, and the interest is C. C means A into 10%. 10% is our interest rate. So A means the beginning balance of loan. Loan into interest rate is called interest. Interest amount is computed on the basis of loan amount and interest rate. So C equal to A into 10%. Always use the amount of A into 10% in interest. And the principal amount can be computed by deducting the interest rate from payment. So the B minus C, that is payment minus interest, equal to the principal. Always use this formula. This method is very easiest. And the ending balance of loan. Ending balance of loan means the beginning balance of loan minus principal paid. That is A minus D. That is the ending balance of loan. And the ending balance of loan of year 1 is the beginning balance of loan of year 2. And the beginning balance of loan, ending balance of year 2 is the beginning balance of loan of year 3. This is the process to compute the loan amortization schedule, to prepare the loan amortization schedule. Let's go. Beginning balance of loan. At first in year 1 there is 10,000 in the beginning balance of loan because the college borrow rupees 10,000 as a loan, and for year 0 or and for year 1, 10,000 is our beginning balance of loan, and put the value of payment for all year, because the payment is calculated and the payment is always equal. We say equal annual installment payment. Equal annual means every year, equal means every year there is a equal, so we can directly put the value of payment for all years once directly. So now compute the value of interest. A into 10. A means 10,000 into 10%, that is 1,000. A means 10,000 into 10% means 1,000. Now compute the value of principal. Value of principal means D equal to B minus C. B means payment minus C means interest. Payment minus interest, that is 2637.96 minus 1000, that is B minus C. 2637.96 minus 1000, we can get 1637.96 as a principal. So now this is a time to calculate the ending balance of loan for year 1. So A minus D. A means 10,000 and D means principal. A means beginning balance of loan, D means principal. Now A minus D means beginning balance of loan minus principal, that is 10,000 minus 1637.96. We can get 8362.04. This is our ending balance of loan for year 1. I again say this is the ending balance of loan for year 1. This ending balance of loan for year 1 is the beginning balance of loan for year 2, because the ending balance of year 1 is the beginning balance of year 2, and the ending balance of year 2 is goes to the beginning balance of year 3, and again the ending balance of year 3 goes to the beginning balance of year 4, and the ending balance of year 4 goes to the beginning balance of year 5. In this way, make a chain, and if you know about the beginning balance and payment amount, you can calculate the interest rate and principal and again ending balance. This is the chain formula. So repeat this process. That is the for year 1, how you calculate this process. Repeat this process to find out all the table. This process repeat again and again, and you have at the end the ending balance of loan is equivalent to 0. Here 0.07 comes due to the rounding error calculation, so it is equivalent to 0. This is the fully amortized schedule. Fully amortized means fully loan is amortized. Fully loan is make a 0, there is no loan at last. Now number B solution. Portion or fraction of interest of third year. Interest of third year represents the payment. That is formula means interest of third year divided by PMT. Have a look on the interest of third year. Interest column, third year row. That is 656.03 is the interest of third year. And the divide by PMT. PMT is equal for all years, so you can use any one PMT payment. Now 656.03 divided by 2637.96 into 100 equal to 24.87. What does it mean? 24.87. What does it mean? It means that the 24.87% of payment is the interest of third year. I said again, the 24.87 represents the 24.87% of payment represents the interest of third year. Again, portion or fraction of principal of fourth year represents the payment. That is equal to the principal of fourth year divided by payment into 100%. So principal of fourth year, Have a look on the principal of fourth year, principal column and the year 4 row. Rupees 2180.12, that is the principal of fourth year, and the payment we know that 2637.96, and we can get 82.67%. What does it mean? 82.67, what does it mean? It means that 82.6% 67% of payment, 82.67% of payment represents the principal of fourth year. It means that. Now the problem D, interest and principal of last year. Look at the table, interest and principal of last year. Last year means year 5. There is the interest of 239.82 and the principal of 2398.14. So the interest and principal of last year is rupees 239.82 and rupees 2398.14 respectively. Now we are going to give you assignment. Please do it yourself. This is assignment and it's very easy. If you don't do this assignment, you are not able to prepare the loan amortization schedule. So if you cannot do this assignment, again you can see this video. Now this all about the single cash flow, and now annuity. Now it's turn to about the annuity. Annuity means the multiple regular cash flow. There is no single cash flow, there is a multiple cash flow and regular cash flow, that is called the annuity. So number 1, even simple annuity. Have a look on color and explanation. Even simple annuity, equal payment are made at the end of each year. Red red, green green, match. Even means equal payment. If the in timeline there is the equal payment, that is called even cash flow. And the simple annuity means, simple means payment are made at the end of each year, that is called simple. Simple means payment made at the end of each year. So even simple annuity means equal payments are made at the end of each year, is called even simple annuity. Have a look on timeline. 0, 1, 2, 3, 4, 5 is our number of year, and rupees 500, 500, 500, 500 and 500. Here is 0, 1, 2, 3, 4, 5. 0 to 1. 0 to 1 is our first year. 0 to 1 is our first year. 0 is the beginning of first year and the 1 is the ending of first year. So the payment are made at the end of each year, means the payment are made at the year end of first year 500, year end 200, year 2 is 500, and similarly. And the simple annuity, simple means payment made at the end of year, and even means there is equal payment. Have a look on each year, there is the equal payment or equal receipt, whatever. There is the equal cash flow. There is the equal cash flow. Okay. There is year 1 500, 2 500, 3 500, 4 500 and 5 500. There is the equal amount. So this is the simple annuity even. For this we can get the present value of annuity. Present value of annuity means PMT, PVIFA. Use PVIFA, don't use PVIF. Be consider about that. PVIFA, I% year is our easiest formula, so it is highlighted by red color. Or PVA equal to PMT into 1 minus 1 upon 1 plus I to the power n upon whole upon I. This formula is you can use both formula, whatever you feel easy. Now if you have a financial table, use the rate formula. If you don't have a financial table, use the black colored formula. So again, this is the all about the present value of annuity. Now we are going to discuss about the future value of annuity. Future value of annuity means PMT, PB, FBIFA, I% year. FBIFA, we also find the factor FBIFA at financial table, or if you don't have a financial table, use another formula PMT equal to 1 plus I to the power n minus 1 upon I. Now number 2, even annuity due, even cash flow but annuity due means equal payments. Even means equal payment, but due means the payment are made at the beginning of each year, or receipt are made at the beginning of each year, or cash flow at the beginning of each year is called the annuity due. So have a look on timeline. 0 1 2 3 4 5 is our timeline. Have a look on the cash flow. 0 to 1 is our first year. 0 to 1 is our first year. 0 is the beginning of year, 1 is the ending of year 1. So 0 to 1 is our first year, and payment are made at 0, that is called payment are made at the beginning of each year, so it is the annuity due. And look, the payment or the cash flow are equal, or receipt the cash flow are equal, so this is even cash flow. So we can find out the PVA due. Due means annuity due, present value of annuity due, PVA due equal to PMT PBIFA I% year into 1 plus I. Have a look on the green color. The red color formula is similar to the even simple annuity. For PVA due, you have to multiply it by 1 plus I. Always remember 1 plus I is the due for. Now, or PMT equal to 1 minus 1 upon 1 plus I to the power n upon I into 1 plus I. This formula is for those who don't have a financial table. So now this is the time to find out the FBA due. FBA due equal to PMT FBIFA I% year into 1 plus I. Again, it is multiplied by 1 plus I. And the another formula also you can use without financial table, and again you have to multiply it by 1 plus I. So you pay attention on this formula. Be sure that if it is a annuity due, then you have to multiply it by 1 plus I. Always remember that. These all are for even cash flow. 1 and 2 are for even cash flow. Now we are going to solve a question. Find the FB, PV and FB of following cash flow. Read the question carefully. The present value of rupees 500 per year. The present value. We have to find the present value of rupees 500 per year. Per year means every year, each year. That is PMT. Equal annual installment or equal annual payments, PMT. So the present value of rupees 500 per year. Rupees 500 per year. Per year means every year. That is called PMT. If in the question there is the per year words, then it will be the PMT. The present value of rupees 500 per year at the end of each year. Have a look on at the end of each year means. End of each year means simple. End means simple, beginning means due. End means simple, beginning means due. Now received at the end of each year for 5 year, number of year 5 at the 10% I. So from A information we can get rupees 500 as a PMT, and 5 year is our N, number of year, and I equal to 10%, and the annuity is simple annuity, not a due. So For B, the present value of 500 per year received at the beginning of each year. Beginning of each year. That is annuity due. For 5 year and 10%. Again the value is same. Only A and B, there is the two difference. One is the received at the end of each year and the B is the received at the beginning of each year. That is simple and annuity due. We have to find out the PBA and PBA due. So for C, the future value of an ordinary annuity. The question itself tells us about the ordinary annuity. Ordinary annuity means simple ordinary annuity. Simple or ordinary, same. So we have to find out the FBA of rupees 500 per year, 5 year 10%. All information are same. Only there is the FBA or PBA, due or simple. And number D, the future value of an annuity due. The question itself tells about the annuity due. So we have to find out the FBA due for 500 per year, 5 year 10%. Now write the given information. Annual payment PMT equal to 500 for all A, B and C, D, and time N equal to 5 year for all for A, B, C, D, and interest rate I equal to 10% or 10 upon 100 equal to 0.1 for all A, B, C, D, whatever. Now A equal to present value of simple annuity. Why simple? Because in this question, in part A, there is the word received at the end of each year. That's why it is a simple annuity. Use the formula, simple annuity formula, PBA equal to PMT, PBIFA I% year on year. That is 500. PBIFA 10% 5 year. Use the PBIFA, don't use the PBIF. Use PBIFA. It's annuity. It's an annuity. So you have to use the. So you can get the value of PBIFA 10% 5 year on financial table. That is 3.7908 and 5 into 500. We can get 1895.40. Or alternatively, we can use the formula method directly. If you don't have any financial table, you can directly calculate it. You can directly calculate the PBA. So put the value of I and N and PMT. Always use I upon 100. That is I equal to 0.1 for 10%. That is I upon 100 in this formula method. Now you can get rupees. Same answer. The answer is same. Now for part B. Don't forget the annual payment. Payment is 500. N equal to 5 year. I equal to 10%. Don't forget. Don't forget about that. Okay. Now we are going to solve the part B problem, present value of annuity due, PBA due. It means that the PBA due equal to PMT, PBIFA I% 10 year. This is the same as previous PBA, and into 1 plus I is new for due. 500 into 3.7908, that is same, into 1 plus 0.1, that is the I value, I equal to 0.1. Use I equal to 0.1. Do not use 1 plus 10 directly. It's a 10 divided by 100. So now we can get 2084.94 as a PBA due. Alternatively, you can put the value of I and N. You can also find from formula method if you don't have a financial table. The answer is same. Or alternatively, there is the another way too. PBA due equal to PBA into 1 plus I, because the value of PBA, the formula of PBA is PMT PBIFA I% N year, same as before, and into 1 plus I. Now you can get the value, same value. Now it's time to compute the problem part C, future value of ordinary annuity. Ordinary means simple. Ordinary means simple annuity. So FBA equal to PMT FBIFA I% N year. Put the value of PMT 500, FBIFA 10% 5 year. Have a look on FVIFA 10% 5 year. You can put the value 500 into 6.1051. That is the FVIFA 10% 5 year is 6.1051. Have a look on financial table and you can get 3052.55 rupees as the FBA. Or if you don't have a financial table, use this formula. If you don't have a financial table, use this formula and put the value of I and N, and the value of I equal to 0.1. Don't use directly 10%. And now you got the same answer as before. And it's time to compute the part D, future value of annuity due, FBA due. That is FBA due equal to PMT FBIFA I% year into 1 plus I. Same, the payment equal to 500 and the FBIFA 10% year equal to 6.1051. That is already calculated as part C in the part C, and the 1 plus I means 1 plus 0.1. We can get rupees 3357.81 as the FBA due, or you can compute by this formula. If you don't have any financial table, you can get the answer same, or you can lastly you can get the FBA due equal to FBA into 1 plus I. Again you got the same formula. Now this is the present value and future value of uneven cash flow. This is the time to compute the present value and future value of uneven cash flow. We already discussed about the even cash flow. Even means equal payment, uneven means unequal payment. There is no equal payment. So consider this cash flow. Uneven cash flow means no equal payment. That is, payment are different in each time. Payments are deferred in each time. So year 1 2 3 4 5 0 1 2 3 4 5, and the cash flow, have a look on the cash flow. In year 1 300 2 600 3 700 4 600 and 5 600. Have a look on the cash flow. There is the different cash flow, there is no similar cash flow. So this is the uneven cash flow. Find the present value and future value of above cash flow at 10%. Now the above cash flow is given and number of year also given, and the interest rate is 10%. Now we can find the present value and future value. Calculation of present value. Have a look on this format. Year, cash flow, we can notate the cash flow as A. FBIF, don't use PBIF, don't use the PBIFA, always use PBIF. If there is the tabulation method, always use PBIF or FBIF. Don't use the PBIFA and FBIFA. Now the present value PB equal to multiply of product of A and A into B, that is cash flow and PBIF table factor. Now the year and cash flow are given in the above cash flow. Year 1 300, year 2 600, year 3 700, year 4 600, year 5 600. And FBIFA, we can see the value FBIFA and put the value serially. For year 1 0.9091, for year 2 0.8264. This is the FBIF table. You can get it the value from table, financial table. And the value of present value is the product of A into B, that is 300 into 0.9091, 600 into 0.8264, 700 into 0.7513, 600 into 0.6830, 600 equal to 0.6209. We can get, and you have to sum. Now you got the total present value as rupees 2076.82. This is the present value. This is the easiest method to calculate the present value from tabulation method for uneven cash flow. Now time to calculate the future value. Again, future value of uneven cash flow. This is our format. Have a look on the format. Year cash flow, we note it as A, and FBIF. If you have to compute the future value, use the FBIF. If you have to compute the present value, use PBIF. Don't use the factor for annuity. So FBIF 10% and the future value equal to A into B. Now put the year and cash flow on the question. And again, the FBIF at a 10% value you can got, but you have to put it from below to upward, downward to upward. Look at the arrow. At the year 5, use 1.0000, and year 4 use 1.1 factor. In year 4, the factor FBIFA is for 1 year. For year 5, FBIF factor 0 year, and for year 4, FBIF factor for year 1, and year 3, FBIF factor for 2, and year 2, FBIF factor for 3, and at the year 1, FBIF factor for 4 year. Now, so be careful about that. While finding the future value, always use these factors from below to upward, downward to upward, always according to this arrow. You have to put the value of factors. Now you got the future value by multiplying the cash flow into FBIF factors. You got this, and you have to sum it up. You got rupees 3344.83 as a total future value. Now you are requested to share and subscribe the channel for upcoming video. Thank you.